Hello everyone, today we will continue to talk about low concentration sulfur dioxide flue gas desulfurization technology, as shown in the figure. Judicial lime for American Combustion Engineering Company. Limestone process flow. National Environmental Protection Agency experiments in the United States indicate that the optimal operating pH of the limestone system is 5.8 to 6.2. The pH value of the lime system is 8. The characteristic of this process is that the process is simple, good economic performance, low workload of operation and maintenance, availability rate above 90%, waste residue can be discarded. It can also be recycled, as commercial gypsum. It is the most widely used type in the world. Flue gas desulfurization technology. Power plants using this process in the United States. More than 80% of the total installed capacity of flue gas flow separation in the power plant. Single machine capacity within the range of 20 to 920 megawatts. The desulfurization rate of high sulfur coal can reach over 90%. Potential defects of traditional limestone process. The mechanism of the equipment is blocked. Corrosion and wear issues. Process improvement, mainly in the absorption slurry. Add a small amount of additives, such as formic acid, to increase the solubility of the absorbent by several orders of magnitude. 1. The gas-liquid interface of the absorption tower, exit flue, gate and baffle, and appropriate materials should be selected for areas, such as mist eliminators, to prevent corrosion. 2. Adopting a dual-loop absorption system. It divides the internal part of the absorption tower into two areas. One is a low pH zone, and the other is a high pH zone. The low pH zone has a reflux of 4.55.0, mainly for the purpose to maximize the utilization of limestone and remove chloride ions from the flue gas to reduce its corrosion on the tower body. Meanwhile, can remove 35% to 40% of sulfur dioxide from flue gas. The purpose of a high pH circuit is obtaining relatively high sulfur dioxide removal rate. Features: 100% utilization of absorbents, avoiding oversaturation, the resulting structural and blockage issues. So, the limestone/lime washing method. Issues that need to be addressed. 1. Equipment corrosion. 2. Structure and blockage. 3. Blockage of mist eliminator. Utilization rate of defluxing agent, and liquid-solid separation. And the treatment and disposal of solid waste, and improve the limestone/lime desulfurization process. So, adding adipic acid limestone method. Adipic acid inhibits the dissolution of sulfur dioxide at the gas-liquid interface, resulting in a decrease in pH value, accelerated mass transfer in the liquid phase, the presence of calcium adipate, increased reactionability between liquid phase and sulfur dioxide, reduce the calcium-sulfur ratio, adding magnesium sulfate, sulfur dioxide as a soluble salt, formal absorption, solving the problem of scaling, double alkali process. First, absorb sulfur dioxide with an alkaline metal or alkaline aqueous solution. Afterwards, use lime or limestone for regeneration. Can solve the problem of scaling, and improve the utilization rate of sulfur dioxide. Dry flue gas desulfurization technology. Spray drying method. It was in the 1980s, rapidly developing a semi-dry dehydration process. Spray drying. It is currently second only to limestone in market share. Lime wet flue gas desulfurization technology. Its equipment and operation are simple. Carbon steel can be used as the structural material. Wastewater that does not produce pollution with trace metal elements. At present, spray drying method, mainly suitable for flue gas desulfurization of low sulfur coal. System for high sulfur enzymes. Conduct only exemplary research. Not yet industrialized. Process flow and equipment. The process flow of spray drying method is shown in the figure, mainly including the preparation of absorbent, absorption and drying, solid waste replenishment, and the four main processes of solid waste disposal. A wet-dry desulfurization process. Market share second only to wet calcium method. The process of desulfurization. It's because sulfur dioxide is atomized. Calcium hydroxide slurry or sodium carbonate solution. Absorbed flue gas with higher temperature. Dried droplets, forming dry solid waste. Popularization of dry waste through bag or electrostatic precipitators. Simple equipment and operation. Low waste volume, lower energy consumption, which is half to one-third of wet method. Main system. 1. Lime slurry preparation system. Produce lime with a particle size of 50 mm. Lime emulsion with high activity. 2. Desulfurization system. The lime slurry is atomized in the absorption tower to form droplet particles smaller than 100 mm. Mixing in contact with flue gas. Complete the chemical reaction of flue gas separation. The chemical and physical principles of this process are: calcium oxide reacts with water to form calcium hydroxide. Sulfur dioxide reacts with water to form sulfite. The reaction between calcium hydroxide and sulfite produces calcium sulfite. Calcium sulfite is oxidized by oxygen to form calcium sulfate. The main advantages of this process: relatively small investment and footprint. The technology of no wastewater discharge is relatively mature. Disadvantage: high quality requirements for absorbers. Most of the desulfurization byproducts are calcium sulfite. Difficulty in comprehensive utilization. The temperature of the absorption tower needs to be sufficiently low to meet the requirements of desulfurization chemical reactions. Requirement to ensure above dew point. To prevent corrosion of equipment and flue. Under the condition of constant calcium-sulfur ratio, changes in the amount of water passing through. To control the outlet temperature of the absorption tower. Influence on flue gas separation efficiency of spray drying method. The main factors include: 1. Calcium flow ratio increases with the increase of calcium flow ratio. The flow rate also increases, but the magnitude of its increase increases from large to small. Finally, it tends to stabilize. 2. The lower the outlet smoke temperature of the absorption tower, the lower the temperature, the higher the desulfurization rate. Removal reaction of sulfur dioxide. The basic condition is absorbent droplets must contain moisture. Thirdly, ash recycling. Improving the utilization rate of calcium. Improve heat and mass transfer conditions. Trends in improving the wall structure of absorption towers. Main process: preparation of absorbent. Preparation of absorbent. It is an absorbent solution or slurry prepared on site. Although lime is a common absorbent, there are also various other absorbents available for selection. Selection of absorbent. It will depend on whether it is easy to obtain locally, and price factors. Desulfurized limestone already used in spray drying method, up to 100+. The typical active calcium oxide content ranges from 80% to 90%. It's the best, because limestone is cheaper than lime. Many users are more interested in limestone. In some industrial sectors, like the beer industry and wastewater, contains hydroxide and soda ash, and these wastewater can be used as a reactant for flue gas desulfurization. When soda ash is used as an absorbent, produce a mixture of soda ash and composed mixture. This mixture can be directly used in the pulp and paper industry. For the lime system, recycled solid waste can improve the utilization rate of absorbent. For sodium absorption systems, due to the absorbent passing through the absorption tower in one go, the reaction is almost complete, so there's no need for a loop. In the lime system, granular lime must be matured to produce a reactive slurry. Absorb and dry boiler flue gas at 120 to 160 degrees Celsius. Feed from the top of spray drying tower. Meanwhile, by installing a high-speed rotating nozzle at the top of the tower, prepare the lime. Spray into droplets with a diameter less than 100 microns. These have large specific surface area and dispersed lime milk droplets. After contact with flue gas, on the one hand, chemical reactions occur in the flue gas. On the other hand, heat exchange between flue gas and lime droplets quickly evaporate most of the moisture and form a low moisture content containing calcium sulfite, calcium sulfate, lime and some unreacted solid waste. In order to effectively remove sulfur dioxide, spray drying, the smoke distribution device and atomizer are the most important devices. Spray dryer, providing sufficient contact time for smoke and droplets, in order to achieve maximum removal rate, and fully dry, solid particles formed by absorbing droplets. Most of the flue gas from the lime system, desulfurization time is 10 to 12 seconds. Airflow distribution device and atomizer, be able to fully mix smoke and atomized droplets, to facilitate the quality between smoke and droplets, and heat transfer, require droplets to be sufficiently small, in order to have sufficient surface area, beneficial for the absorption of sulfur dioxide. At the same time, it should not be too small, to prevent insufficient absorption before the droplets completely dry out, so there are many atomizers used: rotary centrifugal atomizer, and two-phase spray atomizers. The former uses high-speed rotating discs to form atomization wheels. Small droplets generated at approximately 10,000 to 20,000 revolutions per minute. Droplet size varies with the diameter and speed of the rotary table, typically 25 to 200 microns. It has little to do with the supply of this slurry. This is one of its advantages, because in actual operation, feed rate of absorbent, as the flue gas flow rate increases, varying with the concentration of sulfur dioxide, so the structure of the rotating centrifugal atomizer, it's quite complex. The atomization wheel has better wear resistance. In addition, the blockage of spray holes is also one of the problems. Two-phase flow spray nozzle, using high-pressure air to break the absorption liquid into droplets. Its main advantage is that there are no moving parts. To avoid blockages, high flow rates can be used. The downside is that the size of droplets varies with the rate of feed. As a result, the removal rate of sulfur dioxide changes. This is its reaction formula. Calcium hydroxide reacts with sulfur dioxide and water, generate calcium sulfite. Calcium sulfite reacts with oxygen again, generate calcium sulfate products. Solid supply, spray drying desulfurization solid. Typical components of waste. Fly ash accounts for 64% to 79%. Calcium sulfite accounts for 14% to 24%. Calcium sulfate accounts for 2.1% to 4%. Calcium hydroxide accounts for 1.2% to 5%. That solid waste is deposited in the spray drying tower, discharged from the bottom. Fine desulfurization ash particles, as the flue gas is discharged from the lower part of the dryer, entering the bag filter. Bag filters are widely used for collection. Dry solid, reactive alkaline substance, can continue to react with sulfur dioxide in the flue gas. Research has shown that removal of sulfur dioxide in belt dust collectors can account for 10% of the total removal rate of sulfur dioxide. The advantages of an electrostatic precipitator are: it is not very sensitive to condensation, can operate at temperatures closer to saturation, thereby improving the removal rate of sulfur dioxide. Despite the presence of sulfur dioxide in flue gas, removed, however, due to the presence of moisture in the flue gas and the decrease in the volume flow rate of the flue gas, the efficiency of electrostatic precipitator dust collection is still high. The flue gas from the dust collector is discharged by the fan. Dust collector desulfurization ash particles, and desulfurization particles discharged from the bottom of spray drying tower. Recirculation back to the system, continue to use To improve the utilization rate of desulfurization agents. Solid waste disposal. Methods of waste disposal. It varies depending on the type of absorbent. For lime system, when in solid waste, when the amount of unreacted absorbent is less than 5%, solid waste is harmless. The same disposal method as lime can be used. For the system, prudent measures should be taken. Reduce the leaching rate of waste. The final product of spray drying absorption is a potential industrial and building material, but currently, the application of expanding scale is still under research. The advantage of spray drying is temperature control of outlet in spray drying tower, at a safe temperature below but above the dew point. Therefore, the reheating system is reduced. Dry solid waste, reduced the volume of waste. In addition, the flue gas pressure of the desulfurization system is moderate. Low conveying capacity of absorbent. Therefore, the system energy consumption is low. Only 1/3 to half of the energy consumption of wet processes. That's all for today's content. Thank you all.